Hello and welcome back to the Ninox Learning Channel by Nioxis Corporation. My name is Andy, I'm a Ninox programmer and trainer, and in this class we're going to talk about buttons. Now buttons are really a special kind of trigger, and we've had 3 different classes over the course of the last few years where we've talked about triggers. If you've never worked with a trigger or if you want to learn more about them, look at classes 400.08, 600.04, and 600.06 here on the Ninox Learning Channel, and you'll learn all about triggers. In this class, the 3rd class in our 700 learning series, we're going to talk about a manually actuated trigger, a button. This is an object that we can build into our databases, we can place on the screen in any table, and this special kind of trigger allows the user to have great control over when the trigger is pulled, if it's pulled repetitively, how many times it might repeat. The button trigger gives the user the ultimate and highest level of control. So in this class, we're going to look at all of the different ways we can create and design buttons for just about any user interface we might want to build in our Ninox database. Let's begin. Now before we dive into the class, I want to remind all of you that if you go to nioxis.com, www.nioxis.com, and if you are a standard, deluxe, or premier member, click on login and log in to the Nioxis member portal. There you can access the templates module, and at the very top is our brand new template, working with buttons. Everything you're going to see me do here in this class today, you can do, you can access, you can follow along click by click by simply downloading the buttons template from the Nioxis member portal. So with that, let's go ahead and get started. Now here we see a single screen. This is a Ninox screen, and we see a number of different buttons. Every one of them looks just a little bit different, and we use different techniques to create these different looks. But every one of them does the same thing. It tells Ninox, when I get clicked, you do something. And the something that's going to be done is represented by the code block that is associated with the button itself. Now before we dive into building and constructing these screen elements, let's see how each one of them works. Buttons in Ninox fall into 3 categories. Single state buttons are the ones you see at the top, and they are exactly that. They always exist in a single state. They always look the same. No matter whether you're clicking it 1 time or 100, the minute you release your mouse button, the button itself will return to its single visual state. Multi-state buttons, well, there are 2 kinds. There are dual state, and there are buttons that have more than 2 states. Let's take a look at these. Where a single state button always looks the same when it's unclicked, when it's clicked, and when it's released, always looks the same. A dual state button will have 2 different looks, an on and an off, a 1 or a 0, yes or no. This is a binomial construct. The dual state button differs from the single state in that it looks one way when it has been clicked, and it looks a different way when it has been clicked again. Here we see the off state, the on state, the off state, the on state. And we can flip back and forth between these 2 or these dual states. Now, when we consider multi-state buttons, we also need to look at those buttons that have more than 2 visual states. For example, let's look at this arrow button. Here we see a construct rotating counterclockwise 90 degrees every time I click it, and presenting us with a different visual state, a different image every time I click it. This is a multi-state, or to be more specific, a 4-state button. Now there are a couple of more constructs in Ninox that aren't specifically called buttons, but they act exactly like buttons. Those are the choice field and the yes/no field. These two fields are represented with these 4 objects down here. This is a yes/no button representing itself as a checkbox. This is a yes/no button representing itself as a flip switch. And this is a yes/no button representing itself as a slider. This is a choice field representing itself with 2 different options, giving us a binomial or dual state button. And those states are red and green. So here we see at the very bottom button constructs, or more specifically, yes/no fields and choice fields, representing themselves as interactive objects, or what we would generically call a button in Ninox, and these buttons affect the performance of this button here. So buttons can act upon themselves while at the same time, or while they execute specific pieces of code. Now let's see how we built these buttons, because different buttons will apply to different user interface designs and will deliver different user experiences in different applications. The easiest buttons, of course, are the single state buttons. And I'm going to go into administrative mode so we can peek behind the curtain, if you will, and see how each of these 10 buttons was constructed. Let's begin. This button is actually the only one on the screen that Ninox calls a button. It is accessible through the layout element pop-up, which is right here, and it is, of course, this construct right there. We click to apply a button to our screen. We can drag that button to any position we like. We can size the button vertically, not horizontally. This can be as small as that, or it can be as large as an entire row. But it will always be this tall from top to bottom. We can format our buttons by giving it a different background color, maybe a different foreground color, and a different size font. Now I want to warn you, when you make any change to any of the parameters in the styling options of a button, it is going to default to text left aligned, which looks like that. And if you have a particularly big button, that might be a little bit confusing. So remember, when you style these buttons, most often you're going to want to center the text, especially if you're going to use this as a single state button. So that's probably the easiest button of all, because everything you need to do to this button you can do within Ninox. If you're here in Form View, you can access buttons from the Layout element pop-up at the bottom. If you are in Table Management mode, you can go to the Add Layout Element panel on the right, grab a button, drag it over to your screen. Buttons are also unique kinds of objects in that you can have multiple buttons with the exact same label. And there are, in fact, instances where you might want to do that. The other type of button, right below, is also a button. We access it and apply it the same way, either through the layout elements at the bottom or by dragging it in Table Management View from the Add Layout Element side of the object library. The difference here is instead of using text as the name of the button, we used an emoji. Now remember, emojis appear as graphics, but Ninox treats them as text, which means anywhere you could place text, you have the option of placing an emoji. I like to use getomoji.com, where there are hundreds of emoji elements. You simply copy the element off the screen, paste it right in to the field where you would name the button, and then, as you saw me do before, style it accordingly. Now, emojis are by nature small. So one thing that we do recommend is update the style of the button from its default state of normal, which is really very small. We when using emojis, as our button labels, will go to the very large font size in an effort to at least make the emoji as big as possible within the span of the button. And the button, again, can be as tiny as that, a single element or a single block in the screen. It can be as wide as you want it to be, but like the single state button above it, it will always be the same height, top to bottom. And the single state will always be that emoji you chose. Now the third and final single state button that we see here on the screen is this button right here. And this button appears to be a graphic image. Graphic images in Ninox, when applied as a visual state in a button, must be JPEG images. The good news is any JPEG can be used. The bad news, only JPEGs can be used. So if you have invisible backgrounds in PNG files or vector images in Illustrator files, you're going to have to convert them to JPEG type files in order to load them up into Ninox, where they can be used as the clickable element. This single state graphic image button is in fact a formula. Now, why did we use a formula? Well, we have to use a formula because the nature of a button is it should be responsive to the user click. I'm sure by now you are familiar with the image field in Ninox, which can be accessed by adding a field and selecting image. And here we see an image box which I can size to a pretty small or pretty large dimension here on the screen. The problem with an image file, well, there are two. First of all, you cannot associate an action or an activity directly with the button itself or with the image itself as a clickable object. Now let me be clear. You can define code to be executed after the image field itself has been updated. But to actuate or to pull the trigger, if you will, you would have to change the image that appears in the button. There is no clickable aspect to an image field. Image fields do, however, have a very important function in the design of these graphic buttons, these formula buttons. And the very important role they play is they hold the image itself. Let's delete this image field and let's go in and look at the table itself. And here we see a field, an image field called File Icon. This is a true image field. Right now it is hidden. I'm going to erase the word null in the display field only if parameter so we can see this image on screen. And sure enough, this image field, again named file icon, because this is a picture of a file, contains the image that is the clickable button itself. So why did we have to take it from an image field and translate it or change it into a formula? Two reasons again that I mentioned. First of all, a formula has an on-click option, which means you don't have to make a change to the content of the field for a trigger to get pulled. All you have to do is click the field and something will happen. We need the image field here to hold the image itself. We need the formula field so we can associate an action that will happen when the image is clicked with the image itself, and also because formula fields, when they contain images, can be styled. What this means is there is some space here on the left and here on the right that is not covered by the image itself. My ability to go in to the style parameter of the formula and define the background color, and in this case, maybe I would define it as all black, allows me to control what appears to the left and right of the image field itself. Now, when I want the image field and the panels to the left and right of that square field, that square image, to appear invisible or exactly the same as the background around it, I would need to go in and tune the background color ever so slightly, just like that. And now this white formula with the blue circular icon floating on its own white background appears to have no background at all when placed on this white screen. The entire screen is white here in my Ninox form. But again, the important thing to remember, we store the graphic image itself in an image field. We then hide the image field by nulling out the display field only if. We drag a formula field onto our screen, and the formula is the very image field, in this case the file icon field, that contains the JPEG image that we want to have act as a button. And sure enough, that's exactly what we get here. I want to remind you of one thing, or warn you of one thing. The entire reason we took this content of an image field and brought it into this formula by making it the formula in the formula field was so that we could have a clickable action associated with the user clicking the image itself. Keep in mind, if there is no formula in the on-click parameter of the formula field that we are having act as a button, if there's no on-click formula, then the formula field itself will act like an image. And what that means is when you click it, you will open the image. This is the source file in the image field that is the formula for this formula field. Since there's no explanation of what Ninox should do if this formula is clicked, it is simply acting like an image because this formula contains an image. By dropping in any code at all, and in fact I can drop in just the word null, which is effectively no code, what this will do is force Ninox to treat this like a button. So I can now click it. Nothing will happen because the code that's there consists only of the word null, and null is a code snippet that does nothing. But because the code is there, this formula is now acting like a button as opposed to acting like the image that it contains. One more thing to remind you. Notice that the image for our button has a border around it. If I were to go in and really wanted this to be a true button, I would first hide the label so it looks like that. And then, to truly make it look like it's floating on the screen with this invisible background, we will go in to the style parameter, draw a solid, thin border line around it, but the color of the border line will be identical to the color of the form or the screen on which the button is placed. And there you have it. A button that contains an image, no field label visible, no frame around it. We've just covered 3 different types of single state button. The button button, the emoji button, the image button. Let's now move into our dual state buttons. And in the binomial world of technology in general, and Ninox specifically, the 2 logical states are a 1 or a 0, an on or an off. And a lot of people don't know that this particular emblem is exactly that. It is a 1 superimposed over a 0. 1 representing on, the 0 representing off. This button, however, is a dual state button. So there is one look for off and a different look for on. Red is off, green is on. How did we do it? Well, we know we had an image field involved somewhere. In fact, we had 2. We have to have at least as many image fields as there are states for the button that we are building. This button, this dual state button, was built exactly the same way as this single state button. The only difference is this formula refers to 2 different images, where this formula only refers to 1. Let's again go back and look at our table, and we will see 2 more image fields here and here. Let us unhide those image fields by removing the null snippet from the display or invisibility parameter. And let's see what we have. Sure enough, 2 images. 1 image field named on, 1 image field named off. To nobody's surprise, the on field contains the green button, the off field contains the red button. And these 2 image fields are now doing everything and the only thing we need them to do. They are holding the images that are the visual states of our dual state button. Let's go back and hide them, knowing that they're doing everything they need to do, but we don't need to actually see them doing it. So I'll go back into administrative mode, go back to the display field only if, type the word null to ensure that the on image field and the off image field do not appear, and in fact will never appear. Let us now go into administrative mode for the formula itself. Again, this is a formula. Why? Because I can style the background of the formula, and I can associate an action or a block of code to be executed when this formula, which is acting like a button, gets clicked. But how did we get the button to change its visual state? Well, for that, we need one more component. We need to know whether or not the button has been clicked or clicked again. We need to know what state it is in so that when it gets clicked again, we know what state it should go to. we know it's currently red, which means when we click it, Ninox knows to take it to green. If it's green and we click it, Ninox knows to go to red, and back and forth as many times as we want. But for the switch to work, Ninox needs to know its current state so it knows the other state to switch into. How do we do that? In addition to those two image fields that are holding the visual content of the button, and in addition to the formula, which is the button itself, we have one more object. And that is this object right here. And that is this yes/no field that we have named button on. This is a yes/no field. It is currently being hidden. Let's unhide it and see how it works. We've named this yes/no field button on. So when it's checked, that means the button is on. And when it's not checked, that means the button is not on. When the button is not on, it's off. So whatever state it's in, this yes/no field will tell us the current state. And by clicking the button, Ninox will flip it to the other state. When it's off and we click it, it flips to on. When it's on and we click it, it flips to off. And since it can only be one or the other, because there's only two states in a dual state button, those are all of the choices. Let's see how we made everything work. The first step is to affect or actuate the monitor itself. This is the monitor. This yes/no field is monitoring the current state of this button object. When we go in and click this formula acting like a button object, it executes this single line of code. If the yes/no field button on is on or equal to yes, then we want to flip it to be no, off. If, however, it's not on, which means it's currently off, then we want to flip it to on. Button on equals yes. Button on equals no means the button is off. Button on equals yes means the button is on. No is off, yes is on. Let's see that in action. The button is off. We click it, it's now on. The button is on. We click it, it's now off. Whatever it is when we click it, it's going to be the opposite when we click it again. So that's how we know our current state. Button not on, red. Button on, green. Now, the last little piece of magic is the formula itself. The formula itself says, if the button is on, then display the content of the on field. What is the content of the on field? That was the image field that contained the green button. If button is not on, then display the contents of the off field. And what was that? That was the red image button, the red JPEG. So by flipping this switch, Ninox knows what state it's in. And based on the state it is in, it knows which image to present. But remember, our monitor switch, if you will, is hidden. This yes/no field is hidden. So nobody is going to see the behind-the-scenes monitoring. And no one is going to see the behind-the-scenes on green image and red off image. All they're going to see is this formula that contains the image So the formula is acting like a button, and what happens when we click the button? It flips that yes/no field to whatever state it's not in. And that is how we get a button that at the same time changes its state and responds to the change in state by presenting a different image. This is also a dual state button. Like this one, it is in one state or the other. This happens to be visually representing the on-off state. This represents the switched or the unswitched state. It's still a dual state button because it is either in this state or in that state. There's only two states. Now this is a much easier dual state button to build because you do not need a monitor and you do not need any image fields. All you need is a choice field with a single choice and a color assigned to it. So this single choice field has a single choice. The choice is named switch. The blue is the color associated with the switch choice when it has been chosen. Now the name of the field is choice, but that's irrelevant. We're actually hiding the name of the field because we want this choice field to act like a button. And button fields don't have names. The name that appears or the image that appears on the button is the name of the button. So this button is going to be effectively named switch to the end user. We hide the label position, we offer one option, and we give that option a color. Now, I will tell you that the color you assign to the button will appear when the single choice is chosen. And the color will disappear when that single choice becomes unchosen. So you probably don't want to use red because red is really associated with off or warning or error. That's why we chose blue as the activated or switched on color. I'll use a more vibrant, almost neon aqua. So this is what it looks like when it's switched off or unswitched. Click it, now it's switched on. It can only exist in one of two visual states, but the visual states are not image visuals, they are colorized visuals. The name of the button stays the same, and the button lights up to reflect its current state. So these are our dual state buttons, image-based or a choice field with a single choice acting as the button itself. You will note a choice field does not have a what to do if it gets clicked parameter. It does have a trigger after update, and that's fine because an update for a choice field is merely a click. I just updated the field. So whatever it's supposed to do when it gets clicked, it's going to do. I just updated it again. Whatever it's supposed to do when it gets clicked, it's going to do. Which introduces a very important thing for you to remember. There's only one trigger after update. So if you wanted to do one thing when it is switched on and do something else when it is switched off, then you're going to want to have a construct that looks like this. Let the button state or some variable equal the current choice. And then if the button state equals 1, that means the one choice has been selected. Then do this. If it is not 1, then do that, and that is the end of our structure. So first establish, has it been selected or not? If it has been selected, then this choice field will contain a 1. If it has not been selected, this choice field will be null. If the choice field has been selected and contains a 1, do the code in these two lines 3 and 4. If the choice field has not been selected, so the current state is not a 1, execute the code in lines 6 and 7. Now, why the number 1? Because you will note that this single choice is the first choice, the number 1 choice for the choice field. So when the button is on or switched or selected, when it's glowing blue, this is containing a 1. So the 1 code would have been executed. If I flip it off, it now contains a null. Nothing has been selected, so the else code in the if then else construct will be executed. There are a couple of other dual state buttons that aren't really buttons here on the screen, and let's take a quick look at them. This is a button or an object, a clickable object, that is in fact a yes-no field. The yes-no field is named hide button, and when it is on, this button is hidden. When it is off, this button is not hidden. But this dual state object is simply a yes-no field presenting itself as a checkbox. This is the exact same field, another yes-no field named lock button. When it is in the no state, the arrow is not locked, the button can be clicked. When lock button is in the yes state, you can click all you want, it cannot be actuated there, no matter what it looks like. This is a yes-no field presenting itself as a switch. And then finally, we have this yes-no field, which is presenting itself as a slider. This is a slider that is on. This is a slider that is off. If we actuate or affect the counterclockwise switch, which we know is actually a yes-no button, into the other state, where counterclockwise is on or yes, then the button appears to be rotating backwards or in the opposite direction of clockwise, or in this case, to the left. And then finally, we have the visual state of the button itself, which is controlled by this binomial switch. Where these 3 switches were yes-no buttons, this is a choice field, but it's a choice field with not 1, but 2 choices. Now, why did we do this? Why did we use a choice field to change the color? Because we might have more than 2 colors. So let's now turn our attention to this button. This is a multi-state button, but unlike these 2 multi-state buttons, it can exist in one of 4 states, not simply one of 2. But the condition and the operation, in fact, the very visibility of this 4-state button is controlled by these 4 button-like objects here. So let's see how these 4 controls are used to affect and direct the performance of this rotating arrow button. Let's start with the hide button. When hide is yes, button is hidden, invisible. When hide is unchecked or no, button is visible. How did that work? This if then says, if the button is not hidden, then and only then display one of these 8 images, which is to say, one of the 4 red images or one of the 4 green images. But if the hide button is set to yes. Then this no longer matters because the check or the switch to determine which red or which green button is displayed exists inside of an if statement that says only display something if the button is not being hidden. If the button is being hidden, there's no else clause, which means there is nothing to display. So this hide button yes no field controls this outer if then loop. Then there is the question of which way to rotate, to the right or to the left. That is controlled with this yes no field, which is demonstrating itself or presenting itself in the slider format. How is that taken into consideration? Well, we know that how an image button looks is controlled by the formula. Here's the formula that says red or green, or if being hidden, nothing at all. That's the formula. The question now is what to do. The form of a JPEG or image button is controlled by the formula. The function of the button is controlled by the onClick parameter. Let's see what the onClick parameter says. If the counterclockwise is not on, which means it's not counterclockwise, which means it's going clockwise, then if it's in a current state of 1, change it to 2. If it's in a current state of 2, change it to 3. If it's 3, go to 4. And if the current state or case is 4, go back to 1. If it is counterclockwise, then do the else. If it's 1, go back to 4. If it's 2, go back to 1. If it's 3, go back to 2. If it's 4, go back to 3. But what is the it? The it is the monitor. Remember here when we had a multi-state image button? We needed this yes-no field to know whether it was on or off. But for a field that has more than 2 states, it has to have more than a monitor that can only track a yes state or a no state. So what is that monitor? Let's go back and look at our table. And let's look at this particular field right here called phase. This is a numeric field. It is a numeric field called phase, and that is this field right here. This tells us the current phase of this button. Phase 2 is up. Phase 1 is left. Phase 4 is down. Phase 3 is right. Going clockwise. Phase down is 4. Phase 1 is left. Phase 2 is up. Phase 3 is right. So it doesn't matter whether you're going clockwise or counterclockwise, you're always going 1, 2, 3, 4. 1, 2, 3, 4. That's clockwise. If you want a reverse direction, now we're going 4, 3, 2, 1. Look at the phase monitor. 4, 3, 2, 1. This is counterclockwise. Clockwise, 1, 2, 3, 4. This is rotating to the right. Counterclockwise, rotating to the left. Or we now know forward, 1, 2, 3, 4, or backward, 4, 3, 2, 1. And now the only question is, what is rotating forward or backward? The red buttons, or the red images, or the green images? Which brings us to the last component, which is where we began when we looked at our first graphic image button. And that is these 8 image fields. Here's left, right, up, down. This happens to be my red set. Here's up, left, right, down. And this obviously is my green set. Now, how do we bring it all together? Just always remember this. When your button is going to be an image, 1, must be a JPEG image. 2, the JPEG must be stored in an image field. 3, the formula is where you control the form or the visual aspect of your image button. And finally, the on-click is where you control the function. When the trigger gets pulled or the button gets clicked, this is what's going to get done. I want to remind you that downloading the template for all Ninox members is free, and downloading the template, which is unlocked, allows you to see all of this code. And when the code is right in front of you, and you can actually go in and see the different clicks and the different formulas or forms, it's going to be really easy for you to understand what we're doing here. And that is how you can use choice fields and yes/no fields and formulas and actual buttons to give the users lots of different options on how to control the operation of their database. Buttons are one of the most intuitive and easy to understand objects that you can place on a screen. And if you're building software that other people are going to be using, we strongly encourage you to make rich use and consistent use of the button. Thank you so much for joining us in the class today. I hope you enjoyed it. I hope you learned a whole lot about buttons, and I hope what you learned today is going to help you build an even better database tomorrow. Join us in the classroom next week for another Ninox training class, and until then, have fun with Ninox, and I'll see you soon. Bye-bye, everybody.